Good morning, good afternoon, and good evening, everyone, wherever in the world you may be joining us from today. My name is Francesco Del Carpio, and I am the Operations Coordinator for CFAL York. I would like to officially open the 21st session in our Climate Change Emergencies and Cultural Heritage Speaker Series, which is being presented in partnership with Heritage Ottawa and World Heritage Catalysis. I would like to begin today's session with a land acknowledgement. We acknowledge and recognize that many Indigenous nations have longstanding relationships with the territory upon which our campuses are located that precede the establishment of York University. The area is known as Toronto and has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. The territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. As this is an online event, our participants may be joining from various locations, so I strongly encourage you to learn about the traditional land upon which you are located. With this, I would like to welcome our moderator, our speakers, and our participants from around the world. Welcome to our webinar. It is now my great pleasure to introduce our moderator today, Emad Gatas. Emad Gatas is a principal at Goldsmith, Borgal and Company Limited Architects, or GBCA, with a decade of expertise in the conservation and reuse of historic buildings. At GBCA, Emad guides clients through municipal approvals for development projects that require a balance of heritage conservation and intensification. He prepares reports for associated heritage resources and coordinates with architectural teams and consultants. Emad holds a Bachelor of Science in Architecture from McGill University and a Master's of Architecture from the University of Waterloo, and has memberships with the Ontario Association of Architects, or the OAA, the Canadian Association of Heritage Professionals, or CAHP, the Royal Architectural Institute of Canada, RAIC, and the Toronto Society of Architects. He is fully fluent in French and English. Emad, thank you very much for moderating today's session. The floor is yours. Oh, sorry, Emad, you're on mute.
Thought I had this clicked, but thank you very much, Francesco, for the introduction, and for Kurosh and Heritage Ottawa for having this session today. So I'm going to go ahead and introduce the panelists today. We first have Eric Charron, or Eric Charron, who's an architect with Diamond Schmitt Architects based out of Toronto, with over 10 years of experience in the conservation, restoration, and retrofit of heritage buildings in Ontario. With his most recent project, where he led the adaptive reuse of the historic Weston Bakery building in Toronto, also known as the Wonder condominiums, into a residential use. His previous experience includes the restoration of the Dome of the Saskatchewan Legislature in Regina, Canada, and as well as the historic analysis and retrofits to Queen's Park in Toronto, among other notable projects. So thank you very much, Eric, for joining. And also we have Carlos Morell, who is a principal at GBCA Architects, who brings more than 20 years of experience in the preservation and historic restoration and a wealth of knowledge in materials conservation. And since joining the firm at GBCA, he has overseen numerous award-winning projects, including Massey Hall in Toronto and the restoration of stone masonry at Mackenzie Hall in Windsor, Ontario. Trained as an architect in his native Cuba, he was also the chief architect of the Catholic Church of the city of Havana and the surrounding province, working on World Heritage Site of the Cathedral in Old Havana. So just without further ado, I'm going to let our two panelists to dive directly into the subject, because there's a lot of interesting topics to raise with regards to the Wonder Condominiums project. And at the end of the session, we welcome questions. So if you could put them in the chat box, formulate questions into the chat box. I will look into them and ask them directly to our speakers. That would probably be the most efficient way to ask questions to the entire group. So without further ado, you can take it over, Eric and Carlos.
Thank you, Emad, and thank you, Francesco and Kurosh and everyone from the CFAL York team. I'll start sharing my screen. Can I just confirm that you can see my slides?
Yep, they look good. Thank
All
you.
right, perfect. Okay, well, thank you everyone for joining us today for this talk hosted by CFAL York University in Toronto, Canada, as part of the Climate Change Emergencies and Cultural Heritage Series. The topic today that we'll be discussing is climate and flood resistance for heritage buildings within the context of the Wonder Condominium case study that both Carlos and I from Diamond Schmitt and GBCA architects worked on collaboratively over the last 4 years or so. The project was started in 2016 and was opened officially at the end of 2023. So it was a long project, but a lot of great study and lessons learned as a result of this. Part of the agenda today, as part of this talk, we're going to talk briefly about the site and the history of the building because it is a cultural heritage site in the city of Toronto. We'll also be discussing some of the United Nations Sustainable Development Goals in relation to structure and salvaging of materials and reuse of project materials within the scope of architecture, as well as the main topic, flood protection for heritage sites and mitigating moisture to heritage buildings and heritage fabric. So within the scope of the project that we're talking about, we're going to touch on 3 of the Sustainable Development Goals put out by the United Nations as part of the Economic and Social Affairs Department, which is goals that all architects and designers and design professionals and governments around the world are focusing on to deal with the climate change emergency. And the 3 that we're talking about, 11, 12, and 13, are about sustainable cities, climate action, and responsible consumption and production of materials. And these are highlighted because they were the largest item goals that we could achieve within the scope of our project itself. Looking at the context where we're situated, the project is in the city of Toronto, which is on Lake Ontario in Canada, and the site is just east in the Leslieville neighborhood of Toronto, east of the downtown core, which you can see highlighted along the lakeshore. The site itself started as a history with a bakery use back in the 1880s when Brown's Bread set up a informal 2-story wood frame building at the corner of Booth Avenue and Eastern Avenue in what was primarily an industrial section of the city that had a lot of factories. It emerged within a context of a lot of residential blue-collar workers, worker housing that was being built in the neighborhood as a result of all the industrial and factory uses that were going up around it. This is an image of as the bakery grew and its scope of sales and manufacturing expanded, it also expanded on the site and became what we see today as a 4-story brick masonry structure that grew over 30 years between the 1920s and the 1950s. And you can see in the Atlas plan in the lower left corner, the site started expanding to the north and to the east until it eventually filled up almost half of a city block between Eastern Avenue, which you see the main street at the south, and then Queen Street, which is a block north. The bakery was active continuously for over 100 years in the neighborhood, 120 years, creating the famous Wonder Bread product along with other pastries and other bakery products that were distributed throughout the city and throughout Canada. The site did move on and closed operations in 2014, and the city recognized the building for its heritage and for its contribution to the industrial development of the city in 2017, giving it heritage protection status. When Greywood and Altera Developments, local developers in the city of Toronto, bought the site in 2015 or 16, they recognized the character of this building, that it contributed to the neighborhood, and in working with Diamond Schmitt and GBCA Heritage Architects, came up with what we see today in terms of the Wonder condominiums. And this is a view of the original 4-story building and the 2-story additions that were built into the late 1920s and 1930s that were also retained as part of this redevelopment of this property. Just to give you a little bit of context of what was retained of the original site, you can see outlined in red 2 structural bays of the original bakery building were retained in full. The entire structure was saved, as well as the exterior, and then the back part of the building was deconstructed in order to tie in a new construction for condominiums and retail space at the north side. So the left is to the north. The building is significant given that it contains 4 different residential uses. It contains hard lofts, which is in the original heritage building, and then townhouses, which are 2 stories that are along the residential side streets of Logan and Booth Avenue, and then the balance of condominiums above. And it's one of the few buildings that I know of in the city that contain 4 different types of residential layouts in terms of townhouses, condominiums, and hard lofts, all within the same building, as well as accommodating ground floor retail facing the main Eastern Avenue. And you can see this here. The new construction, which is set back behind the existing building, is not, it doesn't overwhelm the existing heritage building. It's stepped back both from the south so that the existing masonry structure is prominent, and then the side streets step back both from Booth Avenue and Logan. They step inward, as well as to the north, the building sets back as well. And part of the character that was achieved in this construction was not just accommodating a readaptive use of the existing bakery and keeping that urban form still legible and quite prominent, but also adding a scale and character which is reminiscent of the other housing in the neighborhood, Victorian housing and worker housing, and keeping that cadence and vocabulary in the way that the townhouse and the building was scaled, so that it didn't look like it was overwhelming the neighborhood, but looked like it was emerging from it and looks quite compatible to it. The building was nominated last year for the Toronto Heritage Awards, and it did win a Canadian Brownfield Network Award in the rebuild category for brownfield remediation, which we were quite happy to accept as a finalist and a winner for that category. So getting into the unit sustainable development strategies, the first item, which was utilized as a feature to highlight, was the salvage and retention of the original building, as well as its structure. So often today we see only the facades in Toronto and in some other locations around the world, where only the exterior facade is retained and the structure is removed behind. The approach that we took here was more of a deconstruction as opposed to demolition, and tying in the new building with structural bays that could be utilized and taken advantage of to turn into hard lofts, with the oldest section of the building, which is highlighted in the green part. So this is what the building looked like before deconstruction started taking place. It was a typical, it's a mass masonry construction, 3 whites of brick with steel structure and concrete floors. So it has original steel beams and columns within the inside, poured concrete floors, and industrial windows that you can see in some of the interior photographs. We also had to remediate a lot of contaminated and dangerous hazardous materials that were used in the inside. We had to decontaminate lead paint on the inside of the walls, remove mercury and other industrial uses that were part of the bakery functions. The deconstruction that you see here, what we have highlighted in red, is the section of the building, of the original 4-story building, that was deconstructed north of the original facade. So that's 2 structural bays. And part of the salvage operations that took place during deconstruction was to save almost 3,000 square feet of the exterior face brick from the original north part of the building so that we could reuse, clean, and then use that material for reconstruction in the new project, both for masonry replacement in terms of upkeep and repair of the original exterior, as well as creating new return walls that would be pivotal and critical in terms of creating the aesthetic and sewing in of the new building to the old building. You can see during the deconstruction process in 2020, we essentially cut the building in half and removed everything to the north, but retained all of the structure and envelope of the original four-story building. And you can see on the left-hand side of the image, the exterior facade of the two-story, which was added to the complex at the end of the 1920s. Here's a cross-section through the proposed new construction, highlighting the section of the original bakery in blue that was saved and integrated into the new building. Part of the challenge with this project was negotiating the floor to ceiling heights of the original building with the new construction, because you can see the original building has 4 stories, but if you look just behind it, there's about 6 floors in the new building. So having to negotiate that was part of the challenge of this project, but ultimately one of the rewarding lessons learned in terms of dealing with heritage buildings. Part of the other salvage operations that took place were the reuse of the original parapet wall terracotta tiles that were removed carefully and then replaced as part of the reconstruction, as well as artifacts from the original bakery building that help interpret that previous use in the new building. And you can see here as completion photos, some of that reused material at the top of the parapet walls, as well as some of the salvaged brickwork that was taken off the back of the original building and then used for return walls that were visible from the street to make the building look seamless in terms of the outside facade and then some of these return walls. And then some of the old turnstiles that were used for the bread making functions in the factory building were reinterpreted as chandelier-like materials and hanging fixtures in the lobby to harken back to that previous industrial use and provide some character and interpretive quality. And I'll let Carlos take over at this point to talk about some of the flood protection measures that were used.
Thank you, Eric. Yes, when GBCA took over this building, we found, go to the next slide, please. Yes, we found that the building that you can see, this is the flood risk that was based on the Regional Conservation Authority that you see in yellow where the building is located. So it was still in the area that have huge impact from the flooding from Don River. Next. So when we get to that building, we found that the building has flooded for several years. During the years has been several times, but the highest that we know about it was April 2012. That was roughly 1 meter or maybe more in the level. Can you see in the right, more or less where the water got? And if you look carefully in that photo, in the left corner of that photo, you see there are some dark spots on the floor, because this is because of the flooding. You see that the paint that was applied to the building in order to make things easier to clean, it was lead-based paint, relatively impermeable, but you can see that the paint is flaking. Next. And when we get inside the building, that was one of the conditions that we normally saw in this level. A lot of flaking paint, a lot of debris, a lot of damage due to the flooding that has been happening in the building for years and years and years. And that make us think that we needed to do something about these things, because the city was working already on the final solution for Don River, but in the meantime, the building has to be put in place and have to be put for new functions next. So we decided to take a look to this from more careful approach, and we found that there are several types of flooding normally in cities like this one. So coastal is very common, is based on combination of high tides and waves. It happens commonly in spring and autumn, of course, in places that have is close to the seashore line. Like in this case, the photo at the top is Havana. I wanted to bring something from my former country, that you can see that is also because of the hurricane seasons and they create heavy waves and make the race of the sea can be really damaging and go very, very far, 2 or 3 or maybe 4 blocks inside the city. The next one is river, which is our case. We're gonna go more deeper later in this case. And also the surface ground water that is normally because of the in the cities that happens with heavy rainfall, normally happens very suddenly, and the drainage system cannot cope with that amount of water in so short period of time, and that's when happens these floodings. Like in this case was very common in that area in Union Station, but this one is specifically from July 2024, not too back in time. Next. So what we found is that when we're doing this research for these buildings, we found that there are several types of flooding that have to be mitigation options that can be applied for heritage buildings. The first one is the wet flood approach, which is involved that this allows the water to enter and exit the building. Mostly what has happened in this building during the years. The problem with this approach is that the foundation must resist the interior and exterior pressure from the water. Okay, and the building has proven that it was not bad doing that during the years. One point that we want to make for these things is when you have this wet approach, you need to be careful when the building gets a flood inside and in the exterior. You cannot remove the water in the interior really fast. You need to do it slowly, more or less at the same level that the exterior is going down to. If not, you can create like it's called like a swimming pool effect, that the water pressure from the exterior probably is too much and can create cracks, fissures, and also can bring the foundation to fail in some cases if it's not well done. Other element in this case is the protection for vulnerable equipment, which is normally involved, if it's possible, raise the equipment from the level, but depending if you have enough height to do these things. If not, you need to use some barriers to close this around these buildings, around these elements, sorry. And we will talk about this later for this similar approach for dry proof. The third would be flood openings for equalization. That's something really interesting to consider, but it has to be work with the mechanical and structural engineers. The problem is that in this approach, as you can see, minimum you have to have at least 2 openings in different side of the building, so allows the water to go inside the building and try to get out at the same time. The problem is that those openings has to be designed minimum 1 square inch per square foot of area that you want to this flooded. Okay, and the bottom from the you can see in this photo the interior grade have to be no more than 1 foot or 300 millimeters from the exterior grade. The problem is that allows the water to stand and goes slowly in these things. Next. So we found also that there are also dry proof flooding. Those are the problem is that the dry flood proofing is the one that allows the prevents the water to go inside the building. But the problem is that the foundation and the walls have to be strong enough to withstand the hydrostatic pressure from the water. We don't know exactly where the level is going to get. It could be so it's have to involve more structural engineers review for these elements, but it's also one approach that can be done. This approach have several four basic elements: continuous impermeable barriers, like in this case shown here in the photo on the left. Is you can see that the windows are removed, are filled with bricks. Other way would be that you leave the windows and you applied a sealant around the windows that has to be applied interior and exterior to make the positive and negative pressure from the water. But this would be applied for doors and windows, utility penetrations, slabs, etc. So it's going to be a little bit hard in bricks like heritage buildings that are done with bricks. Try to make this approach filling in this way. It's not going to be easy because you have the bricks. You don't know how many cracks, fissures, and open joints you will have to allow the water going inside. But it's another option that we can make this. Waterproof membranes, as you can see in the photo on the right. Okay, it is also very common to seal completely and avoid that the water goes inside the building. Next. The final for these continuous impermeable barriers are flood barriers that can be temporary, removable, or even permanent. The photo on the right, you see that is the white gate is installed permanently. So it is when the floods happen, it is closed, and the building in the interior are buildings in the interior are protected. This one on the left is a hardware store in Darlington. As you can see, they are in a place that they cannot do this other approach. What they decided it was to raise the floor and install ramps for accessibility and stairs to make these things easier for the people going inside the building. Next. So again, like in the wet approach, the flood-resistant interior for the core areas, like in this case, for example, a mechanical room. In this case, they cannot raise the floor. What they did, it was install a watertight door to when the floods comes, they close it, and the equipment is normally in good safe from the floods and these elements. Next. The final approaches would be flood shields for the exterior wall openings. Like in this case, you can see that is on the left is something that is removable. Okay, you see other photo on the right. So there are different approaches that can be taken in these cases, but in cases like this one, you need to be careful because the as I said, the bricks is gonna be can allow probably the water go inside. We don't know if the wall is it will stand all this pressure, but it's another type of approach that we normally can consider for heritage historic buildings in general. Also, the final would be internal drainage system. That is the primary method to remove the interior water, through a system that is gonna be installed in the building. Also, very common is gonna be installed backflow valves to allow that the system closes and there's no sewage coming from the sewage coming to inside the building for making this. The problem with all these approaches is going to be always that because of the climate change, we have seen that, as you can see in the initial photos, that the level of the flooding can change every almost every year or every few years. To put this on perspective, I can tell, for example, when I left my former country, it was back in 2005. The city of Havana was the regulations were for hurricanes 175 kilometers per hour. At that time, the the there were changes and they increased up to 200, because the problem is that because of the climate change, flooding, hurricanes, all these elements has becoming more and more not only frequent but more intense in general in every part of almost every part of the world. So that means that maybe some of these approaches are not going to be completely efficient, and probably we need to give some some wiggle room to make these things as better as possible for heritage buildings. Next. So based on this, all this information that we gather from this building and everything, we found that the best approach for this case, specifically for Wonder Condos, former Weston Bakery, it should be probably a combination of continued impermeable barrier and raised floor in the ground level. Next. So that means that we needed to get probably the target elevation to protect the building. It would be 70.33. Next. So that means that this corner that you can see highlighted in red in both in the plan and in the photo, it has to be protected with this impermeable barrier, and all the entrances in that area should be a combination similar to what we saw in Darlington, steps and ramps to make these entrances accessible. Next. So in this case, you can see the waterproofing installed at the lower level. Okay, we needed to apply cementitious sparging. The foundation was ready for making these things, because this was from the early 20s building. So yes, it's gonna be something that is feasible, installing these dimple drainage boards and other elements. Next. So in this case, Schmitt, I think that they did a very good job preparing these details. As you can see in the photo on the right, installing this the drainage board and these elements. Next. And you can see in this photo, this is something installed to get that watertight membrane around the building. And it has to be perfectly sealed, but at the same time, this area is completely reversible, so you can remove these elements in the future, and you can see again the brick exposed, but at the same time, in this moment, it was completely protected from flooding. Next. So again, the long-term flood solution was finished in fall 2024 by the city, and now that area is no longer susceptible to any flooding, thanks to this work that created a new urban wetlands and habitats, a new urban island. So that means that the area honestly does not need that impermeable barrier anymore. This is the now that you can see the downriver condition post 2023 and how it was compared for these ones in this area than it was before when we started the work back in 2015, 2016, or around that time. So based on these things, we can see that the building achieved, that you can see here, a photo of the waterproof membrane that was installed, and it would be probably it's time to be removed if necessary for making these things and show the brick again as it used to be. Yeah. Next, go ahead. Thank you.
Thanks, Carlos. Yeah, that was a great description of that process in dealing with the flooding. I wanted to also touch on a few of the resilience measures that the project took to deal with moisture, because as we know, mass masonry buildings, they're exposed to the outside, but part of making this building feasible for residential use and to make it thermally comfortable was to also insulate the inside of the building. In the past, when arts groups and various organizations took over old factory buildings, they wouldn't necessarily be occupying a space that was insulated. They were cold in the winter, hot in the summer, and that was also the case for this building. And you can see on the inside walls, it had plaster renders over the existing mass masonry structure. When we started revealing the inside and taking off those renders, we also discovered that some of the assemblies of those walls was not necessarily all brick. Some of it was terracotta, some of it was concrete block. It was a real mishmash of different materials that were used on the inside of the building that we didn't know because it was all covered up. And when we started pulling all that material away, we thought we were only dealing with brick. And in some cases at the ground level, we were dealing with terracotta tile. And on some of the upper floors, we were dealing with solid masonry. So one of the challenges in trying to find a way of insulating this building to make it comfortable for residential use was to find a strategy to apply insulation to the inside and not the outside, because you want to see the exterior masonry, which is part of the heritage fabric. So our approach was to use an offset stud wall on the inside of the heritage walls, the outside or the exterior walls, and to install maximum 2 inches of closed cell spray foam insulation. The reason we used that as opposed to a mineral wool was because 2 inches of closed cell spray foam still allows for a certain level of moisture migration to allow the exterior brickwork to dry out to the inside. If you apply too much insulation to the inside, the wall gets cold in the winter and stays cold, whereas originally these buildings functioned as drying out through heating that was lost from the inside. So, and all of the warm temperatures inside the factories dried out any moisture that got into these walls. But in applying just 2 inches of closed cell spray foam, it still allows a certain degree of drying capacity for the outside heritage walls. And you can see these photos during the fit out and construction of the residential uses, the spray foam insulation that's installed between the stud walls, and then a fireproofing gypsum board applied to that. And then these images, which show the final layer, we added a veneer brick to give that aesthetic of the heritage brick again, even though it's not the original, it's the aesthetic that was desired for the hard lofts, but in keeping the original steel beams and columns and intumescent painting them for fireproofing and leaving them exposed, we still get very tall ceilings, 12, 13 feet in most cases, with the exposed concrete floors and that highly sought after heritage loft aesthetic, which these buildings can offer so well. And part of the other measures that we did as part of this project, which is a resiliency measure not just for this building, but for the city, was to apply at least 60% of the rooftop as green roof, extensive green roofs, which allow for water retention. One of the other measures that we put in place was a water cistern at the parking level, which retains 100% of all the water that falls on the site. And during heavy rainstorms with an overflow tank that would hold the water and then use it for irrigation and a slower release to the city if the tank got filled, so that the storm system does not overflow into the storm, the municipal catchment system, which is where we saw that photo earlier in Union Station. Toronto still has issues with heavy rainstorm events in the summertime where we get a massive amount of rain in a very short period of time, and it mixes with the the sewage system in an overflow capacity, and in that case overflows into the lake. So the more projects that are able to retain 100% of the water that falls on site on the property, either through soaking up through green roofs or water cistern capacity, it helps alleviate that pressure on the municipal systems. And Toronto has a green roof bylaw, so every new building in the city is required to put a green roof or a high reflective roof system to both reduce heat island and to account for water mitigation measures. And here we see the project in the context with the city behind downtown Toronto just to the west. And thank you very much.
Thank you very much, Eric and Carlos, for this for the great presentation you gave. A pretty good overview of the techniques and strategies you've used for any kind of climate mitigation here. So I see there's already some questions being asked. I'm going to start by asking a first question. And this is, I guess, something that always interests me in terms of the dealing with heritage properties and the approvals process as well. This is probably either for Carlos or Eric. When you've looked at the different scenarios or the different strategies to fight against the flooding, whether it's like a wet proofing or dry proofing, how are like approvals or heritage authorities involved in that decision-making process? And did you have to kind of demonstrate the different pros and cons of every scenario when you had to provide the approvals to the city?
Okay, so I think that in cases like this one, most of the time, at least the heritage authorities in Toronto, they rely on the consultants' expertise to make these things. One way or the other one, they can be applied for depending of the each building. Each building is completely different. If they are on the cities, like in this case, heavy dense city, or if they are installed or built in other environments that are not so heavy, that can be different approaches. That approach, it depends of what you believe that should be the best for your building, and normally they rely on us to make these things. The only things, for example, like in cases like this one, the good approach that Diamond did is applying this impermeable barrier as reversible. So yes, it can be addressed. The main issue, which is the flooding and the damage that flooding can cause in the building, and it can be removed later if somebody wants to take this time to remove it. So normally, as I said, they rely on us on these things.
Great, thank you. And all right, so I see there's some questions about the Carly Connor, who's from Ontario, about the deconstruction. So I know there was a lot of interesting factions about deconstruction here, where some materials were reused. And the first question is, who was the structural engineering team that you work with for the deconstruction project?
Thanks for the question. Yes, it was intuitive structural engineers that we worked with throughout the project from the design phase to mitigate both the deconstruction of the north part of the site and also the very careful integration of the new structure with the existing. It was quite a complicated process that involved dealing with the interface between the existing heritage building and the new building floor by floor, because we were encountering different conditions at every floor, and because of the different heights of the new building versus the existing, it was like sewing together an apple to an orange. So I was there every 2 weeks with the structural engineer, kind of working our way up the building and sewing the pieces together as the building grew and met the heritage building. I saw that Carly also asked who the deconstruction contractor was, and that was Lehman. Lehman Group. They both did the structural concrete for the new building, as well as the deconstruction of the existing building. And because of the complex nature of the bakery, with having to remove some staircases and old elevator shafts, we had to deconstruct a number of access points to get into the heritage building during the process, and then pour floors to match the floors of the existing building, where we had to take out stairs and elevators. So that was part of the bringing together of the old heritage fabric for the new uses.
Yeah.
I-
And also, sorry, and also that during the design process, we realized that there are some areas that are going to be, even for the four-story building that was retained as much as possible. There was stairs, former stairs that had to be normally, that elevation had to be reconstructed almost completely. The problem is that, as Eric mentioned before, the building had different materials, and they had also steel lintels installed based on the stairs. So that means that when we tried to rearrange the windows in some of these areas, it was almost impossible to do it, salvaging existing elements have to be deconstructed, have to be carefully removed, and put it back later to suit the new design, which, by the way, involve enlarging some of these openings in order to make this livable, because it was made for a factory.
I had I guess a segue to that in terms of the elements that perhaps in the beginning of the project that you wanted to deconstruct or to salvage, but you realized later on that they were not possible. Did you encounter some of that during the project, and can you give some examples?
We did, in fact. There were some bays, like I was describing, where we had elevators and stair cores that the windows were not compatible, because you had landings with windows that would have ended up in the middle of a new floor when you extend the floor of the original building across. So what we had to do was deconstruct the entire exterior and then rebuild it as a single white brick rain screen using the salvaged heritage brick material. That was an example of one of the towers that you see in the presentation along Eastern Avenue. The building has these kind of almost like a castle, two towers at the end. And the tower in the middle had the elevator and stair core. And on the Booth Avenue side, there was always an intent to keep the full length of the four-story building, but the northernmost bay had various modifications occur over the years while the bakery was operating, where they put new chutes and openings in the facade for industrial inputs, like the sugar and hoppers and doors and things like that. And when we uncovered the inside walls, we actually discovered steel beams had been cut. So in trying to reuse that facade, where we had anomalies of an entire steel beam cut in half, we had to actually deconstruct that portion of the wall as well, and then rebuild it in kind at the end of the project, and make it look as it did, and use the same coursing and return the building to the same aesthetic as it had.
Also,
Right.
what we can mention this also, Emad, is that the clay tiles that Eric was referring before, yes, we found that normally it happens a lot in all these old historic buildings. The current we couldn't find current factories that can make exactly the same clay tiles that they were. It happens something similar to slates, that they vary in thickness, sizes, and everything. So is when we say salvage these things, sometimes you can salvage everything, but you cannot install together. So you need to make it a decision that you say, okay, this area is going to be completely the clay tiles that we salvaged from the original building, but in order to don't mismatch or make something really odd, sometimes you need to take the decision, keep these ones as a future replacement, okay? But install a new ones because in this case was the same. The clay tiles that we found, they were different in size and dimensions, were not exactly the same width as the original, so we had to tweak a little bit the details to make this suit the new design.
Yeah, these are common challenges we find on these buildings. There is a question from Marnie Pardee. Could you please provide more background on your decision to use spray foam insulation rather than the mineral wool insulation? And is it considered, well, yeah, is it now considered reversible? So I can let
Well,
maybe Eric respond to
yeah.
that.
Okay,
Sure.
yeah, so yeah, go ahead.
Oh, no, feel free. Take it away, Carlos.
Yes, so anyway, so it was always a challenging approach for these buildings. We understand that spray foam is not easy to be reversible. It can be, but it's cost labor intense, so it is technically speaking, it's not reversible. The problem is that we need to take the decision for mineral wool. It can be applied in these cases. We don't say that it's not a good approach. Normally, when we try to apply this for heritage buildings, even more in these cases that the wall assembly was not completely brick, was as Merrick mentioned, mismatched with brick, clay tiles, even concrete blocks sometimes. So it was harder to make a decision to these things. It was found that the 2 inches spray foam insulation uh, still allows the brick slowly release the moisture, which is the normal intent of all these assemblies originally. This in this case it was the thickness is a three wide, the equivalent of 3 wide, which is good for storing moisture from the rain and everything, and release this later in the atmosphere, the exterior. But it has to have mechanism from the interior also that helps move this moisture out or in, depending summer or winter. And we found that this 2 inches spray foam is gonna be probably uh, not perfect. We understand that, but at the same time, the best thing that we need to do when we apply insulation for heritage buildings is to try to control how the moisture gets inside the building. And we found two basic ways to make these things: spray foam or a liquid applied vapor permeable approach, which both of them are not so easy to be reversible. There are other methods that can be installed, but also it depends of the client if they want to go to that route. There are some membranes that are completely reversible that you can install as an air barrier on the interior. Because in these cases the approach have to be taken from the interior. You can install some of these ones, but they are expensive, and now they are more common. But at the time when this product was developed, were not so easy available in Canada at that time. There are some things from ProClimate, in some kind, for example, in Tello, they have some of these options that we have proposed for other buildings installed against the wall that can refrain or control how the moisture gets inside the building. That's the main purpose of making these things. It was a decision that was not easy. I remember that was very, very challenging. Eric and myself, we studied these several approaches. Even we studied the ventilated masonry approach, but it was too complicated to make these things perfect for a building so big in this case that the client decided to go to this option. Eric?
I think part of the decision making was also the fact that the walls of the original building were not just solid masonry, because there was such a a combination of different materials, a ventilated approach was not feasible. If you had a solid brick wall all the way up, maybe that could work. But where you have hollow clay tiles and concrete block with only one weight of masonry on some floors versus 3 courses of masonry on others, using that approach or a ventilated approach across the whole building was just made no sense and wasn't feasible. So this spray foam approach was a way of dealing with the entire building in an equal manner that worked and performs the same way across the whole building, as opposed to doing different approaches on different floors. Even on the ground floor, where it's retail space, where it's not occupied, 20 like all day long, where you don't have living spaces, we did not insulate the ground floor so that you could leave the outside walls exposed. And even in that case, they have a whole kind of potpourri of different materials on the inside walls, which is part of the character of the building. So we're leaving that exposed for the retail space, and they can choose to leave that as is or cover it, or they can make that decision as those are occupied.
So one final comment about this is that, for example, was installed only to provide better thermal comfort to the suites in the second floor to above. We understand, and you can see in the details that were shown, we're going to have thermal breaches everywhere because the concrete slab is embedded inside the brick masonry. So we understand that it was only to provide better thermal comfort and make the building more sustainable regarding the consumption of electricity and how much do we give to the exterior from the insulation, lack of insulation that most of these buildings uh, do in the release to the atmosphere too much emission.
Okay, thanks both. This is always a challenge to determine what kind of insulation to use here. One more question. I want to pop up these 2 questions here. So from Evan Oxland, thanks for this great presentation. I'm wondering if you prepared any flood emergency response plans for or with the facilities management or tenants. And did it incorporate any heritage-specific response protocols, such as managing water-saturated masonry, balanced drying regimes, efflorescence, et cetera, So was there any flood mitigation plans that were prepared?
So I can speak to this a bit. Because we were dealing with the Don River floodplain when the building was under construction, we used the exterior waterproofing approach to the foundation walls of the heritage building, as well as using waterproofing around the new construction foundations. So we essentially created a bathtub condition all the way around the site. So and because we waterproofed up to that floodplain datum of the 78-330, only the north portion of the site and where you have access to come and access the underground levels for the parking ramp and that, all the levels, the waterproofing around the entire property went up to that datum. So in theory, you would not get flooding in the basement levels. So we didn't have to necessarily come up with an emergency response plan if the parking levels were flooded, because technically they shouldn't. And now that the Don River plugs have been pulled, the risk has gone down even more so. In terms of saturation of the masonry, we're allowing the brickwork above ground of the original building to dry to the outside. We stripped all the paint off on the inside, which would traditionally restrict drying and the slow release of vapor inside the wall outward. So we pulled off anything that might stop that. And as we were talking about with the spray foam approach, it allows a certain amount of vapor permeability for the wall to dry. So we might have some levels of efflorescence a little bit, but that should dissipate within a year or so of the building being finished and reaching an equilibrium in terms of heating conditions.
Perfect. Thanks for that. And then the last question, it's always like an interesting topic about insurance. Faride asks, in your opinion, to what extent do insurance liability or warranty concerns influence decisions around material reuse in heritage projects?
Carlos, can you speak to that?
And that's the last
Yes.
question.
Okay. So that's not going to be very easy to respond, to tell you the truth. The insurance regarding the insurance for reusing materials and these things, it depends. Probably we need to do. I'm not a specialist in insurance, so I cannot speak exactly for all these things. But I can tell you that, for example, depending what materials are we talking about, one material would be probably easier to reuse than other ones. For example, in this case, the brick is very easy well, not very easy, is easier to reuse than, for example, the steel or the concrete. For example, the concrete is impossible to reuse it unless it is kept in place, like in this case it was done. Regarding the materials, wood can be salvaged depending how you're going to salvage these things. It can have effect on the approach that the basically for the specialist structural engineers and these elements, the wood when this reused, for example, we take the wood beams, they can be reused. There are no data for most of these materials, and the current code sometimes does not consider these materials as the new materials, of course, and they don't have data to support these things. So it will depend of many things. There are ways to calculate this the resistance of these, for example, for fireproofing and all these challenges that we normally have in buildings, but that it depends of the material. It depends if the authorities wants to accept that studies or not, because this has been there is a study from, I think, that to 2020 or something like that, or maybe a little bit earlier. I don't recall in this moment at the top of my head, and they probably don't accept these things so easy. You need to convince, but it happens always at all times. Exactly the same happens with the smart vapor barriers, even when they are not completely fully accepted by the OBC or everything. All the tests that have been done now is accepted on the approval process, and we can see more commonly using all these new materials related to heritage in some of these buildings. But again, it should be take case by case, and not all the materials can be very easy to reuse. For example, brick, very easy. Final comment. A brick that can easily install a new brick, it could be cost probably $5 per brick maximum. When it is involving a salvage brick, unless you have any technology involved, doing this by hand could be up to $25 or $30 per brick installed. So that, okay, that depends, many things depends of these things. About insurance, I cannot speak too much about this, but in general, that's what happened. We have seen that happen for heritage buildings and the materials that we can reuse.
That's a topic on its own, essentially. So, all right, I think we're a little bit over, but I wasn't sure if Francesco or Ali, there's a final wrap up, but I wanted to say thank you to everyone. I see he's just popped up.
Oh yeah, thank you. Yeah, I just wanted to also just thank everybody. Thank you so much to Eric and Carlos for presenting today, taking the time to be here as well. Ahmad, thank you so much for joining us today and moderating the session. Thank you to everyone in the audience. It was a great participation, great questions. Yeah, thank you so much for a wonderful presentation. Thank you to Kurosh for helping us put the session together and the whole series. And thank you to our partners, Heritage Ottawa and World Heritage Catalysis as well. And with that, thank you so much to everybody. I just want to remind everybody of a couple of things. This is a monthly speaker series on the first of every month. So just as a reminder, we will have another session. I believe June 2nd is the first Monday in June. And also that this session is being recorded. So if anyone would like to revisit it, or if anybody knows somebody who couldn't make it today but would be interested in the topic, please share it. It'll be up on our YouTube channel probably within the next couple of hours. So yeah, just one last big thank you to everybody. It was a wonderful session. So thank you so much. And I hope everybody has a great day.
Thank you.
Thank
Okay.
you, Carlos.
Thank
Thank
you.
you, Eric.
everyone.
Thank you, Jonas. Inspiring speech. Thank you.